Hello again. In this video, we're going to begin talking about the material from section 4.7, which is on L'Hopital's rule. Now, we're actually going to return to a subject that we talked about in chapter 2, which was on limits. And you may remember that in that chapter, we occasionally ran into these limits that had these indeterminate forms of like 0 divided by 0, or maybe plus or minus infinity divided by infinity. And the way we handled those in chapter 2 was we tried to simplify the function in some way to make it determinable. So what we're going to do in this section is we're going to look at an alternative way to handle some of those indeterminate forms using L'Hopital's rule. Okay, so let me show you some examples where we can use L'Hopital's rule to evaluate these indeterminate forms, or these limits that have these indeterminate forms. So in this particular example, if we try to evaluate this limit using substitution, notice that when you plug a 1 into here, you get 0 divided by 0. Now what that really means is, as x is getting closer to 1, this top polynomial is getting closer to 0, as well as this bottom one. And so that's giving us this indeterminate form of 0 divided by 0. Now please note that this top polynomial never actually reaches 0 because x never reaches 1. So just keep in mind that as x is getting closer to 1, this polynomial is getting closer to 0 but never actually reaches it. Likewise for the bottom. Okay, x is getting closer to 1 and this bottom polynomial is getting closer to 0 as that happens, but it never actually reaches 0. Nonetheless, we're not able to evaluate this limit using substitution because it's just giving us this indeterminate form. So one way around this to use L'Hopital's rule, which is what this section is about. Now, in chapter 2, we would try to simplify this and maybe get some kind of cancellation. You might want to try to factor this top piece and see if you can't get it to cancel with the bottom piece to make it determinable. But we're going to do something different in this section. So anytime you have an indeterminate form of either 0 over 0 or maybe plus or minus infinity over infinity, you can use L'Hopital's rule. And here's what L'Hopital's rule says. It says that when you take the limit of f of x divided by g of x, and you get one of these two forms, either 0 over 0 or plus or minus infinity over infinity, then you can actually evaluate this limit by looking at the limit of f prime of x divided by g prime of x as x approaches this number a. One thing I want you to keep in mind is you can't use L'Hopital's rule if you don't have either of these two forms. You must have one of these two forms in order to use L'Hopital's rule. Okay, so what it says for us here is that since this is it's giving us an indeterminate form of 0 over 0, we can evaluate this limit by looking at the limit as x approaches 1 of the derivative of this top polynomial, which is 3x squared plus 2x minus 2, divided by the derivative of this bottom polynomial, which is just 1. Notice that's good news for us because now when we try to use substitution to evaluate this limit, we actually get a determinable form. When you plug 1 in here, you get 3 plus 2, which is 5, minus 2, and that's equal to 3. So this limit is actually equal to 3. Okay, so you can see how powerful L'Hopital's rule is. Okay, so let's look at another one. Okay, so let's try to evaluate this limit. Now, using direct substitution, we're going to get e to the 0 minus 1. And notice that e to the 0 is equal to 1. And so this ends up equaling 0. Now again, that means as x is getting closer to 0, this top piece is getting closer to 0, right? But it never actually reaches it. And of course, on the bottom, this is getting closer to 0 as well as x gets closer to 0. So we do have an indeterminate form of 0 over 0, which means we can use L'Hopital's rule to evaluate the limit. So L'Hopital's rule says this limit is the same as the limit as x approaches 0 of the derivative of the top function divided by the derivative of the bottom function. Okay, so the derivative of the top one would be, well, the derivative of e to the x is just e to the x. And then the derivative of this would be -1. And of course, the derivative of that constant would be 0. Okay, and then on the bottom, the derivative of x squared is just 2x. Now, something interesting happens here. Now that we have this form, we can try direct substitution, and notice you get 0 or e to the 0, which is 1 minus 1. So this is approaching 0, as well as the bottom. So we're getting the same indeterminate form of 0 over 0. Well, that's okay. We can't evaluate this limit because it's indeterminate, or it's an indeterminate form, but we can still use L'Hopital's rule, right? As long as we continue to get 0 over 0, or maybe plus or minus infinity over infinity, we can continue to use L'Hopital's rule. So we're going to use it again. Okay, so let's take the derivative of this top piece, and we're just going to get e to the x divided by 2. And now we're going to try to evaluate that limit. Now again, L'Hopital's rule says these two limits are the same. And the good news is we can actually evaluate this limit. Because as x is getting closer to 0, e to the x is getting closer to 1, right? E to the 0. So this is approaching 1. And of course, this is equal to 2. So by substitution, this is just equal to 1/2. And that means this limit, the original one that we had, the limit of that is actually equal to 1/2. Okay, so you can continue to use L'Hopital's rule as long as you're getting one of these two forms until it becomes determinable. Okay, let's do one more. Okay, so in this one, notice that as x is going to infinity, this top piece is heading towards infinity, as well as this bottom polynomial. And so we have this indeterminate form of infinity over infinity, and therefore we can use L'Hopital's rule to evaluate this limit. Okay, so we're going to take the derivative of the top one, and that's going to give us 12x squared minus 12x all over 6x squared minus 10. And then we're going to evaluate the limit of that as x goes to infinity. Now notice you still get infinity over infinity. Okay, and so that means we can use L'Hopital's rule again. Okay, so the derivative of this top one would be 24x minus 12, and the bottom one would be 12x. And again, we end up with infinity over infinity. Okay, and so we can use L'Hopital's rule one more time. And the derivative of the top here would be 24, and the derivative of the bottom would be 12. Then, of course, as x is heading towards infinity, we're always getting a 2 here, right? 24 over 12, so this is approaching 2. And so that's the limit of this original function as x is approaching infinity. Okay, so L'Hopital's rule is a very powerful rule that we can use to evaluate limits. But again, I want you to be careful. You can only use L'Hopital's rule if you have one of these two indeterminate forms. Okay. If it's a different type of indeterminate form, then you can't use L'Hopital's rule. What we're going to do in the next videos are look at some other indeterminate forms that are different than these where we're not allowed to use L'Hopital's rule initially, but we're going to rearrange them, rewrite them, until we get them into one of these two indeterminate forms, which will allow us to use L'Hopital's rule, and then we can evaluate those limits. Okay, but we'll talk about those in the next video. Okay, so I hope you found this video helpful. Thank you for watching. Bye-bye.